Okay, this is the introduction to friction, and friction is a force that tries to actually prevent motion. So just a little note over here. Friction acts against motion. Or the attempt to move. Or the net force trying to cause motion. It doesn't cause motion in its own right. That means that friction, when we do the calculations, mu r, the friction, is a maximum value. It can be less. The actual friction in a situation, the friction in a situation can be less than that. There's your side note. And the definition of friction is the body, the force generated when two surfaces meet. It needs to be found by experimentation because depending on the different size of the material, the nature of each material, that mu can change. So we're going to actually work out what's happening with this problem and find out about friction. So we know that there's a force acting on it for friction that they call F, and F is less than or equal to mu r. That means we also need the R, the reaction force. Now be careful about reaction. It is not always going to be the same as the weight. It is in this case, but we will see some examples in a minute where the reaction force can be different to the force being applied here. So let's do some calculations. So to be able to work out what's going on, we need to find out what R is, we need to find out then what friction is, and then we can work out if there's a net acceleration. So we start off by looking in the vertical direction. And I'm going to say vertically positive is up. We're going to try and work out the motion. Well, we don't think there is going to be any motion. There's no forces net acting. So our mass, the 10, is times by 0. Acting in the positive direction, we've got the force of the table upon the block, which is the reaction force. That's our table on block. So the reaction table or surface on block or particle. And acting against our positive direction is our weight. And weight is downwards from our diagram. So minus 10 g newtons. Rearrange it, and for this case we find R is now 10 g. And I would add it to my diagram as I go through. So now we can find the maximum friction. And the maximum friction that they call F, F is less than or equal to our mu, 1/2, multiplied by R, which is 10 g. That means my friction is less than or equal to 5 g. Finally, to find out what's happening for this problem, we say horizontally what's happening. And I'm going to say positive is to the right. So we now put in to an equation, we've got our mass times the acceleration it's going to generate, so that's 10 times the acceleration. That's my motion part, which is equal to the force being applied, the thrust, which is 3g, minus the friction. And friction is a maximum of 5g. So what we need to think about now is, if there was no motion, is friction. What force does the friction take? So 0 equals the net forces my friction is no net for motion. This is all other forces and this one is friction. So together we can find out that the friction is maximum, or that the friction generated this time is actually 3G, not 5G. If this is bigger than 5G, then the friction would only be 5G. And what we did yesterday was we wrote in 5G and then corrected for it. So we said minus 5G, but correct for 3G. So our next acceleration, so A, is 0 meters per second squared, i.e. no acceleration or deceleration. It does not mean it's not actually moving. Yes, it does. Yes, there would have to be motion. If there was motion, then this could actually generate friction. We would have a moving friction. So if there is a particle is moving, if the particle is moving, this G could change. So this is a clarity that I need to make in the lesson. So if moving F would equal 5G, if stationary, this is the maximum. Okay, so we can generate an acceleration from it. Do another problem similar to this. So again, we're a stationary block. We've got a different force being applied, and I'll run through this one quickly because I'm going to make an extra example. So into here, we've got our reaction force, and we've got μr as well. So we've got reaction and we've got the friction, which is less than or equal to μr, our maximum force. We also want to know is there an acceleration, which we're saying is positive to the right. So we chuck in our values for vertically. We know that there's no net motion. So 0 is our motion. That is equal to the reaction force of the table upon the block minus the weight of the block. So again, we get the reaction force is 10G at the moment. Find the maximum friction. μr. And again, it's still mu is a half. We're keeping the same situation going through. So we're going to do our calculation. 1/2 times 10G gives me 5G newtons again. That's the maximum force I can have. So to create our horizontal motion, what can happen is we'll put in our blocks and we'll put in the acceleration, the weight, multiplied by A. That's my motion equation. So motion equals thrust in the positive direction minus the friction. So thrust is 6G. My friction potentially could be 5G. As 5G is bigger than as 6G is greater than the 5G, we are now able to apply the full friction to resist motion. So this equals G. So my acceleration is 1/10 of g meters per second squared. And there's another problem that I will put together now. Okay, so we've got a situation here where there's no actual force trying to make motion, but it is under motion, it is moving. This is a case that I didn't show in the original lesson. So we put in other forces we know might be acting. So we've got force of reaction, we've got F, the friction, which is less than or equal to mu r, and we've got no actual forces being applied. Because it's moving though, there will be friction, and the friction can take its full amount. So very quickly go through the same process vertically. Positive up, we've got zero motion must equal the reaction of the table minus the weight. Motion is zero vertically. So my reaction force must equal the weight, which is 10 g newtons. This leads me to my friction maximum. So we get friction is equal to mu r, or less than or equal to mu r. So it's less than or equal to 1/2 times 10 g, which is less than or equal to 5 g. Now, because there is motion, this work is actually happening. Because we have motion, the whole friction, all of the friction is applied. So this is how a friction on its own can cause a body to come to a stop.